How you going? This is the first of 4 videos on OSPF. This one is the point-to-point OSPF, where that router is connected via serial to that point there, so point-to-point. Another one would have a router connect to a switch, so these 3 routers will connect to a switch in the middle. That will be a broadcast multi-access network. So slightly different, very similar stuff but different. We'll later on do a multi-area OSPF, so the first 2 will be single area, and that's where we're going to start. And the last video I'll do will be modifying some metrics and putting a bit of authentication on that sort of stuff. So, video 1. OSPF is open shortest path first. It's slightly different to RIP and ERGRP in that it's a link state routing protocol. So this router on the bottom here, router 1, will send out its link state, so the state of this link, the state of that, the state of that, the cost of it to get to them, and whether they're up, down, whatever, and send it to that router and to that router at the top there once it's all configured. So let's say router 3 down the bottom here gets the state of the links from router 1. It will then build its own database and its own path through an algorithm called shortest path first to find out what's the best path for it to get to this network. And it could be up that way, it could be across there, but it works out itself. It's not advertised like RIP, saying RIP as a distance vector will say, well, its path is 1 hop to get to here. That router up there will say, well, it's 2 hops to get through to this network for me, and this one will go, well, I'll go the 1 hop. It's a bit smarter than that. And ERGRP is also a distance vector, but it's enhanced and it has a degree of smartness to it as well. So anyway, let's build the basic OSPF and get it up and running, and then have a look at a few things in there. Okay, so let's hop in. We're on router 1 down the bottom left here, so we'll go configure terminal and router, and we'll put a question mark in there. There's OSPF, that's the command we want, and we add a local process ID, so I'll just put a question mark there as well. It can be anywhere between 1 and 65,000. I'll use 10 for this router. Now if you've played with ERGRP, you'll have to have the same value on every router, because that's the autonomous system. It is the autonomous system, sorry. It's the area that you're actually managing, the whole range of your scope of influence, if you like. So in OSPF, this is only local to this router. We do it differently. Okay, so we're in OSPF. First thing we actually do is put in a router ID, and this is in dot decimal notation. So for router 1 in this case, I'm just putting 1.1.1.1, and that's my router ID. And there's 3 different ways you can actually acquire this. One is this way, which is the best. The second way is if you had a loopback address on this router, it'll take, or a range of them, maybe you had 3 loopback addresses, it will take the highest loopback address and make that the router ID. So you can use loopback addresses. The third and the worst option is to actually use the physical addresses. So in our case, the highest physical address would be 192.168.10.254, which is this interface down here. Putting your router ID in is almost a name for it. It's a preference. Putting in an IP address that may or may not be up at some stage can lead to a lot of errors later on with getting the whole network to reform. So chuck that in, make sure you do that. Okay, next one I do, which is the same command for RIP and ERGRP, is passive interface, and I'm going to not want to send information down my gigabit Ethernet. I don't want to send and receive information from this network for OSPF. So far so good. We now advertise through the network command the networks we're absolutely connected to. So we'll give you the standard option, then I'll do a slightly different option on the router on the right, and we'll just get the third one up and running. Okay, so my network commands is my network number, then the wildcard, which is the complete inverse of your subnet mask, and then area that you're going to belong to. And to start with, we just play with area 0, but it's not the best option for you. Later on we'll change that. So network commands for other directly connected, so the 12 network and the 10 network, 12.0.0.0, and then the wildcard for that, because it's a /30 network, then that's the inverse of the subnet mask, and we add that to area 0 as well. Now the same for area 10, or not area 10, network 10, all added to the same area because we want them all to play together. So in EIGRP, that autonomous system number that I talked about has to be the same. In OSPF, the areas has to be the same for the networks that you want to participate. This 12 network up here, area 0 is what we're saying with. It'll start advertising up here, sending hello packets up to router 2. Router 2, when it connects to the 12 network, it also has to use area 0. It cannot use a different one. Adds a nice error. And that's it. Let's just show our running config just to have a quick review of those commands. So router OSPF 10, that 10, local process ID. Our router ID is 1.1.1.1 in dot decimal notation. Passive interface, we said we don't want to send updates out this path, and there we've advertised the absolute networks of directly connected IPs on our system. And that's it for this router. The router at the top there will have a slight difference because we've got a gateway of last resort. But let's pop onto our router down the bottom right here, so router 3, and we'll add our commands in there. So configure terminal, so router OSPF, and just to be different I'm going to put a 11 in there, so router OSPF 11, and again that process ID is only local to this router. So my router ID, in this case, they have to be different in OSPF. They can be the same in EIGRP, but they have to be different in OSPF. They should be different in EIGRP, put it that way, but they can be the same number, which can lead to nice errors. I'll do passive interface for gigabit 00 here, and then I'll put my network commands in. So I'll put in the 11 first, 172.20 next, and then I'll put in the 10 because I want something to talk about when these form an adjacency, and we'll talk about that in a minute. So 11 with the wildcard and area 0. Then my network command for 172.20, now that's a B class address, so the wildcard for that is 0.0.255.255, and again area 0. Now network 10, as soon as we connect that in, and we're saying area 0, so on that side we've said that this router wants to participate in OSPF down this path to router 3 in area 0, and we've put that configuration on router 1. Now we're just about to add this configuration into router 3. Once we do that, we've just done it there, these should form an adjacency, and there it comes, nice, on time. So OSPF adjacency is formed. We now have a neighbor. We've got two neighbor routers. Our local process ID is 11. The number of our neighbor is 1.1.1.1. That's the router ID. Through our serial port is where we've found this adjacency. So that's good. We've actually put in everything in there that we need to, so let's just double check. So show run pop down. Router ID, passive interface, and the network commands of our directly connected networks. I did say I was going to do different commands on there, and I'll go through them in a minute, but let's just have a look at what's actually happened. So if we show IP route and hit our spacebar, then we have acquired two new networks via OSPF. There's that one, and there's that one. So there's O is OSPF, the front, and there's this other network down there. So what have we got? We've got the network number, so 192.168.10.0 with 24 bits in the subnet mask, so that's advertised. I'll come back to these in the middle there. It's found through our serial interface, which is connected to almost like a gateway address of 10.0.0.1, which is the IP address on router 1. Now, in this little square bracket area here, we have the second bit, is 65, and that's the cost or the metric used by OSPF. So OSPF uses a sum of costs. So this router 1 has advertised out its link state of this network, the 192.168.10. So it's a LSA type 1. So type 1 just says these are my link states, and it's advertised those out. And this router's picked it up and said, well, to get to this network, that router, its cost is 1. Down this path, my cost is 64. And I know these figures, so that's okay. So if I add the two together, that gives me a cost of 65. So OSPF just uses a sum of costs to work out the best path to a destination. So if all these serial links are 64, then the cost, once we configure router 2, it'll have a cost up this way of 64 plus 64 plus 1, so 129 will be the cost up that path. It chooses the best path, which is 65. So, good. We can see the cost to this network, 12 network, is 128. So 64 down this link, 64 up that link. There's a cost of 128. Okay, just to finish off with this a little bit, 110 is the administrative distance, or the trustworthiness of this protocol to this router. So 110 is the default for OSPF. If you haven't seen, or if you remember, or if you haven't, EIGRP is 90, so it's more trustworthiness as far as these routers are concerned. And RIP was at 120, which is less trustworthiness. So, good. Let's go on and configure this router up here. So we're on router 2. So conf t. We'll play around with our commands a little bit. So our router is OSPF, in this case 12. Why not? Let's just put on passive interface gigabit 00 and 01, and our router ID of 2.2.2.2. Again, it has to be different between all our routers. Okay, so we've got the basics in there. Now, our network command here, we can play around with different values. So if I do, and I won't enter these, sometimes they work, sometimes they don't in packet tracer, and it just leads to funny little errors. We'll end up doing it correctly. But we can change up some things. So my network up here in the background is a 192.168.111.0/24, and the IP address of this router is 192.168.111.1. So if I actually type in 192.168.111.1 and say that my wildcard is all zeros, and I plug that into area 0, then I can use the absolute address. And I've put an extra 0 in there, so I've got carried away with my fingers there. So that would actually work on physical gear. So that's an option for us. We won't put that in though. what we can do is modify this up a bit and say, look, I want any interface that is configured on this router that starts with 192.168. So I've modified my command there a little bit. I've put in 192.168, the first two octets, and then I've put my wildcard as 00, so I only want to match those first two octets. And I said that any interface in there on this router that starts with 192.168, I want to advertise that network that that interface is on. So that would work as well. We can also do the mega version as well, which says I want to match any interface and plug that into area 0 and send that across my network. Now that would work on the router on the bottom left and the router on the bottom right, so router 1 and router 3, because we want all those interfaces to be propagated across area 0 and OSPF. What we don't want on router 2 though is this connection that is our gigabit 01, because that's our internet connection. We don't want to propagate that value into our network, so we won't use that either. So let's get in and put our normal commands in. So network 192.168.111.0. The wildcard for that is that, and the area we're connecting to is area 0. We'll now put in, sorry for going shorthand if that's not your flavor, 12.0.0.0, and that's should form an adjacency down this path, and we'll put in the 11 one as well. Now there's our 11, and we should form an adjacency down the other path for a neighbor of 333. Okay, so waiting for these notifications is a good thing, because if they don't work, you need to fix it before you move on. If you just plug everything in and hope for the best, you will have errors and you'll have to undo a lot of stuff. So be very patient and understand what you're expecting. So up there, our adjacency is process number 12 for us up there, because I've just chosen a different number. My neighbor there is 111, which is that router down there, and it's coming through our serial 000, which is that interface there. Down on this path, if you like, we've got another bit of syslog messaging for us. So OSPF has told us again, process 12, our neighbor is 333, and through our serial 001 we found that path down there. Okay, so let's have a look at a few extra commands that we can play with OSPF. So show IP route, just to have a look at our routing table now, see if it's looking all good and correct. We have again two paths, equal cost, 128 to this network down here, so it's going to load balance to that network there. We've got 172.20.0016, which is a cost of 65. That's what we're expecting, so I'm happy. And we've got a 191.68.10.0 with a cost of 65, so I'm happy with that as well. So that looks good. So let's have a look at some other things. Actually, just quietly, there's no gateway of last resort, so we will have to configure that in a minute. But if we show IP OSPF and put a question mark there, we've got a few different options for us. So let's have a look at our neighbors. We'll hit enter there. It says this is when we formed an adjacency. Actually, no, it's not. That's the dead time. It hasn't received an update for a while, so let's do that again, and you can see the change. So it'll count down. I'm trying to remember. It's normally 4 times. So normally with OSPF, hellos, and you might have to double check this because I'm scratching my head here. Hellos are every 10 seconds, and the dead time is 4 times the hello, which is 40 seconds. So if we don't receive a hello within 40 seconds, we assume our neighbor's gone down, and we reconfigure everything. And OSPF is quite quick at rejigging, so it's not the end of the world, it's quite quick. And we're back up to 37, gotta love it. Okay, so let's, instead of show our neighbors, let's look at our database. And we'll stop there because there is extra ones we can play with, but we'll just show IP OSPF database for now. And these are actually our link states. So we're using LSA 1s, and it doesn't actually say it there, but that's the link ID, the advertising routers, a few other bits and pieces have come in, how many links have actually been advertised. Not so much 5, but that tells us what the different states of information is. And that's our local ID. Our process ID is 12, so we're getting a fair bit of information out of our router there. If we want to clear IP OSPF process, we can renegotiate everything, and that's probably more important later on when we're using multi-access networks, because sometimes you need to reform your area board designated router and backup designated. We're not playing with that at the moment. Okay, so far so good. Let's finalize our configuration. If we show our running config, at the moment we don't have a static route out to the internet. Now this is our gateway out to everybody. So let's put in a default route. Gee, I'm good on a IP route. Go to the end, jumping way ahead, and we're going to send it out to our internet. So we're on router 2, so gigabit there. Next hop address is going to be 200.20.20.2. So 200.20.20.2, because it's a potentially, again, connected to a switch type arrangement, we put the next hop address, so we're saying go exactly there. Okay, so now router 2 has a gateway of last resort. Router 1 and 3 need one, so let's give them the gateway of last resort through OSPF. So router OSPF process 12, and we use the same command that we used for RIP. Now EIGRP is different. It does a redistribute, but default information originate will say send this default route from here in OSPF to these other routers. So let's just have a look. Show IP route. Gateway of last resort is set. There's our static with our candidate default asterisk, and it's saying where it's going to. So that's good. Let's have a look at router 1. And it's still got a bit of information about adjacencies, so that's good. It's been a while since we've been here, so we've timed out. So if we show IP route in there, it says our gateway of last resort has been set. It's to the 12001, which is the IP address of this interface and that serial, to every network on the planet. And we'll notice a slight change in here. The metric is given as a 1, so it's not that far away, so because it's candidate default. It's got this little E2 put into there. And E2 is a different type of link state. So it's a type 2. This router has become something called an area border router, actually an autonomous system border router, because that's an autonomous system outside, and internally we have an autonomous system inside. So autonomous system ASBR, autonomous system border router. So show IP OSPF database type 5, actually external link states, of course it is, sorry, and that type 5 LSAs are from ASBRs. So good, we're all up and running. That is it for OSPF on a point-to-point network. Getting it up and running. No errors. Not many. Only me. And we're up and good. Thank you for that.